Hello friends, today I'll be talking about the osmotic power generation. Now my talk would include the need for green energy, as this is a form of green energy. What is actually an osmotic power generation or power process? Then it's the process of osmosis, background, the current use of osmotic power in the world, operation of the osmotic power, and the commercial setup, the feasibility of an osmotic power plant, the membrane technology and its power potentials, improvement in the power output with its advantages, disadvantages, environmental impacts, and finally the conclusion. Now coming to the need of green energy. Now we all know that fossil fuels are non-renewable sources of energy. Now, what is this non-renewable source of energy? That means in due course of time, it will slowly get extincted. So, during this process, down the years, there would be total consumption of fossil fuels and we would not have any source of energy. Now, in order to have certain sustainable form of energy which can go down the years and which would not environmentally impact, is what is the need for green energy. Now coming to the combustion, when we go ahead with the non-renewable sources of energy like fossil fuels, now they produce a large amount of harmful gases. Now among that we have carbon dioxide as the main culprit for global warming. Now this global warming has a very bad impact, environmental damage. So to avoid all these things, we go ahead with the research in the green energy area. Now when we talk about renewable sources of energy, for that matter any of the form of energy, we would see that the main sources of renewable form of energy could be found in the most unlikely places. Now in order to harness this renewable form of energy, all we need is to exploit them by knowing the correct right know-how. Now one such potential point where renewable source which can be a renewable source of energy is estuary. Now what is this estuary? Estuary is a point or area where a river meets the sea or ocean. That means when we say river, it is fresh water meeting the salt water or the saline water of sea or ocean. Now how actually would this point help us in generating energy? A simple phenomenon. The phenomenon that helps is osmosis. Now what is osmosis? Now if suppose we have a beaker which is separated by a semi-permeable membrane, that means which allows only certain solvent particles or molecules to pass through it. If a beaker is separated through a semi-permeable membrane and one end of the membrane is a concentrated salt solution whereas the other end is a dilute salt solution, then the process of osmosis is such that the solvent molecules tend to move from a lesser concentrated solution to a more concentrated solution through this semi-permeable membrane. Now as this solvent molecules move to the higher concentrated solution, obviously the height of the concentrated site increases because of the addition of the water molecules. Now how does this height help us in generating power or being a green source of energy? Now in this diagram we can clearly see that one end we have water and on the other end we have the concentrated solution, and both are separated at the U-tube end by a semi-permeable membrane. Now I have already discussed that the water molecules move from a lesser concentrated solution to a more concentrated solution. So in this U-tube you have water flowing from left tube to right tube, thereby increasing the height of the concentrated solution. So the osmotic power is the energy available from the difference in the salt concentration between the sea and the river water. Now for that matter, we can consider over here water as the fresh water, and the concentrated solution can be a salt solution, which can represent the sea water. Now what happens in this process is that during this power generation, it converts this pressure differential between high salinity and lower salinity into hydraulic pressure, which can in turn be used for generating the power. Now coming to the background of this osmotic power. Now this osmotic power has an impact from 1950s, but not much of research was done on this, but the development came into picture in 1990s. Now a European company called as Statkraft has developed an osmotic power plant in 1998, and a prototype of it has come into picture, which generates electricity, and in 2009. Now where exactly can we locate an osmotic power generating plant? Now I have told you that an estuary is a point which is the potential area for this form of renewable energy. So the optimum plant location area would be the estuary, and the main thing for this kind of a power plant is that they do not need a bigger area to be formed in order to generate the power. Now we all know that the basis of this technology is osmosis, and the major impact that happens is for the membrane, because the membrane allows the water molecules from the fresh water to move towards the seawater, thereby increasing the hydraulic pressure on the seawater side. So it is very important to know how the membrane impact this process. And as we all know that since there is a salinity gradient, this movement will continue till the equilibrium is maintained. Now in order to generate power continuously, we have to always see that the equilibrium is not maintained. If the equilibrium is not maintained, then the water will continuously be flowing to the salt water side from the fresh water side. Now before going into details of osmotic power generation, we would see the current world use of the osmotic power. Now it is a very new term or technology for us to understand what is an osmotic power, but some parts of the world have already started harnessing energy from these estuaries. Now the European country Statkraft, this company is the main technology developer and has opened the first osmotic power plant in Norway in 1998, and this prototype has started generating electricity from 2009. Now since Europe is the first country for in Norway we had this osmotic power generating plant, which is built on an estuary, so that we'll have a continuous supply of fresh as well as saline water. Now in Japan there is an osmotic power plant, but here it is slightly different than that of Europe, because in Europe they have taken the fresh water and the saline water from the ocean, but in case of Japan they have taken the salt water from a desalination plant, the waste product of a desalination plant, where the water that is thrown out will have high concentration of salt, and the fresh water is from a sewage treatment plant. And with the help of this combination of fresh and salt water across a semi-permeable membrane, they are able to generate electricity. Now coming to Canada, in Canada, Hydro-Quebec is the place where they have developed this osmotic power plant, and they intend to supply 14% of their renewable source of energy in 2020. Now, after knowing what is osmosis, what is the current power, osmotic power throughout the world, let us go ahead into the operation of the osmotic power. Now, this diagram shows the basic units that are required in an osmotic power plant. Now, if we see from the top, we have the seawater flowing into the water filter, and at the below we have fresh water flowing into the water filter. Now, what is the use of this water filter? Both fresh and seawater can have impurities, debris, and can clog the membranes, the semi-permeable membrane modules. So this would again damage the membranes, because 80% of this osmotic power plant is 80% of the cost of this osmotic power plant is used for the membrane development. So once the membrane gets damaged, it takes a lot of cost to again refurbish it. Now, this is the reason why generally we try to maintain the membrane modules. Now, nevertheless, in 7 years, these membranes have to be replaced. Now, after this water is filtered on both the sides, they are led into the membrane modules. Now, we can see that the seawater passes through a pressure exchanger and comes into the membrane module. Now, what is the use of this pressure to be developed on the seawater side and not on the freshwater side? If we see to the right hand side of the diagram, we can see that the water being supplied to the turbine is from the seawater side. So if the pressure of the seawater side is more than that of the freshwater side, then we can have a high pressurized stream of water flowing through the turbine blades, which can generate electricity. So for that matter, we pressurize the seawater that comes in from the water filter. Now, when these come in contact with each other through a semi-permeable membrane, then the water molecules or the solvent molecules from the freshwater side move towards the seawater side through the semi-permeable membrane, thereby increasing the pressure of the seawater to a higher level. Now, once it increases the pressure, actually the pressure that gets developed is sufficient to create a head of 120 meters. Now, this pressurized water is made to flow through the turbines. Now, this jet of water in turn helps the turbine blades to rotate, thereby generating electricity. We can harness this through a generator. Now, if we see before the turbine, there is a stream of pressurized water going into the pressure exchanger. Now, this pressurized stream of water actually helps the fresh seawater coming through the water filter to get pressurized. Now, this is what is the commercial setup of an osmotic power plant. Now, we can see that the seawater entering the water filter and moving into the pressure exchanger. Now, the fresh water on the other side enters through the water filter and then moves towards the unit. Now, these units, if we see, the seawater and the fresh water are separated by semi-permeable membranes, or we have membrane modules over there. Now, because of the salinity difference, the water molecules from the freshwater side tend to move towards the seawater side, thereby increasing the height of the seawater. Now, as the height of the seawater increases, it creates a head, and then this high head of water helps the water turbine to move efficiently or to rotate efficiently, thereby producing power. Now, coming to the membrane technology. we have already discussed that the semi-permeable membranes are the membranes that are generally used for these kind of technology for power generation. Now, what are the ideal properties of the membranes which would help in generating the osmotic power, or which would help the solvent molecules to move freely to the saline water side? The first thing is it should have high water permeability. That means it should allow the water to pass through it very efficiently. It should have less salt permeability or low salt permeability. Now, in this case, we should have low salt permeability because if it has a high salt permeability, there is a tendency that the salt molecules may move from the seawater side to the freshwater side, thereby causing the level of water on the freshwater side to go higher, which is a reverse osmosis process, which we do not want. So we always go ahead with a membrane which has low salt permeability. Now, it should have low attraction or less attraction to foreign substances, because if it attracts foreign substances, it is going to go and clog the membranes, and these clogging would damage the membranes. Now, there has to be high pressure differential on the either side, and it should be cost effective, because we know that the cost of the osmotic power plant, the 80% of the cost of the osmotic power plant goes into the membrane development. Now, what are the power potentials? Now, the potential factors would depend on membrane technology, would depend upon the concentration of the salt, would depend upon the point where it is located, would depend upon whether there is continuous supply of fresh water or not, and so on. Now, Statkraft estimates a power potential in Norway of 12 terawatt hours, which would provide Norway with 10% of their power needs. With it, the estimated European potential is 170 terawatt hour per year. Now we can see the difference over here. And whereas the global estimated potential of power by osmotic is 1655 terawatt hour per year. So there is a huge difference between what is being generated now and what is the current need of the state. Now, how these power gap, how can we bridge this gap of the required and the produced amount? Now, the first thing that we can do is the water flow. We can increase the flow of water both at the seawater side as well as the freshwater side, so that there is continuous flow of water which can generate more amount of electricity. The next thing that is there is the high salt gradation, because if there is a higher salt gradient, then the movement of the water molecules from the freshwater side to the saltwater side through the semi-permeable membrane would be high. Now, once the water molecules moving to the saline water side is high, the pressure of the saline water keeps on increasing, and ultimately that helps in attaining a greater head, which would be more efficient to produce electricity. Now, next is the better membrane conditions. Now, I have told you regarding the different ideal properties of the membranes. So the membrane should be selected very carefully in order to see that all those needs are met. The next is the optimal temperature conditions. See, the osmosis process varies with the temperature. So we always have to set an optimal temperature condition so that the process takes place efficiently. Now, these are the areas that are still to be explored. So there is a lot of potential of research work in this light. Now, as we have known that osmotic power is a green source of energy, now we can say that there is almost no emission of greenhouse gases, then we can say that there is it would be green and clean energy. There is no dependency on climate conditions, because we do not depend upon the rain to generate the electricity, like in some cases in hydraulic turbines. What instead can be done is, if there is a power plant which is built at an estuary where there will be a sea or an ocean and a river flowing into it, then it doesn't actually depend upon any of the climatic condition until and unless it is too harsh. Now there is a steady and predictable amount of output, and we can have adaptable it can be adaptable for small and large power generating stations. Moreover, it is scalable and or modular in design. Now, why do we say it is scalable or it is a modular design? The efficiency of the power plant can go up or less by altering the number of membrane modules. So, if suppose there is a need of high power to be generated from the same osmotic power plant, then the number of membrane modules can be increased in order to have the greater head. Now, in the similar fashion, if we need a lesser capacity, then the number of membrane modules can be reduced. Then there is a good potential for power plant sites, because an estuary is a point actually where there always lies a habitat. So that place would be a good place for the power plant, because we can have employment at that place. Then we can reduce the transmission needs. The major thing over here is, wherever we have the load center, there we can place this osmotic power plant. It can be placed at an industry, it can be placed in the basement of an apartment, anywhere, because it doesn't need huge elements to generate electricity. So if these kind of power plants are set near to the load areas, then the transmission needs would reduce. Now, what are the disadvantages? The major disadvantage over here is the membrane. Now, if there's a high risk of clogging and gradual degradation of the semi-permeable membrane, because these foreign particles or dirt, dust come and clog these membrane holes, which doesn't allow the water molecules to flow across it. If this doesn't happen, there won't be any rise on the other side, on the salt water side, and hence, since the head is not developed, there is not much of pressure onto the turbine blades, which would help in generating the power. Now, there is always necessity of pressure filtering, pre-treatment of fresh water. Now, this is what I have already discussed, that if we have fresh water and saline water directly coming into the plant, it should be filtered first, it should be pre-treated first, so that it is efficiently acting as a working fluid in that case. Now, it needs to have a periodic membrane replacement. Now, when we talk about a periodic membrane replacement, it generally gets damaged every 7 years. So, it needs to be replaced every 7 years. Now, coming to the initial cost. The initial cost of these power plants are too high. Now, if we compare with other renewable sources of energy like solar energy or wind energy, when solar and wind energy were in conception, the cost of generating electricity from there was also high. Now, with due research throughout down the lane, the cost of generating power through solar, wind, tidal, all these kind of energies have gone down. Now, it's the same case for the osmotic power generation as well. Now, since it is in a very infant stage, the cost that is being incorporated for setting up a power plant is too high. Now, as it goes into research to a greater level, slowly we'll have technologies which can develop better permeable membranes with a lesser cost, which would in turn reduce the cost of setting the power plant. Now, what are the environmental impacts? Now, since fresh water, sea water, all these are continuously being moved, there can be sediment displacement on the river bed. Now, along with that, there can be shoreline erosion also. Shoreline erosion means on the shore there can be a lot of erosion and the depth at the shore may increase. It may also sometimes impact the water quality because the brackish water again goes back, which would affect the local aquatic animals and plant species. But this has not been much reported yet. Now, the changes in the flow rate and current direction, this is for the river. Now, if there is some change in the flow rate due to some obstacle or current direction, then obviously this is going to have some impact on the power generation and vice versa. Now, careful selection of where the inlet and outlet are placed can help lessen the impacts on the ecosystem, and we can go ahead with a lesser amount of environmental impacts. If we see these impacts, these are much less than that which is produced by the renewable sources, non-renewable sources of energy. Thank you for your kind attention. And if you like the video, please share and subscribe. Thank you.